On the morning of April 8, 1943, over the grey waters off occupied France, Oberleutnant Tegemeier eased his Focke-Wulf 190 into a climbing turn at 18,000 feet. The Channel winds rocked his canopy as he scanned for the returning stream of American bombers from their assault on the Renault works near Paris. What appeared instead made him doubt his own eyes. 7 enormous fighters, each one massive beyond belief, descended in loose formation toward his grup. These were not the nimble Spitfires he had come to know, nor the twin-boom P-38 Lightnings that had recently joined the fray. They looked like flying bathtubs with wings. Meyer, with over 60 confirmed kills and fame for pioneering the head-on attack tactic that had devastated bomber formations, felt curiosity instead of fear. Intelligence briefings had mentioned a new American fighter, the Thunderbolt, but reports dismissed it as clumsy. Fully loaded, it weighed nearly 8 tons, twice that of his Focke-Wulf. Aerodynamics alone suggested it would be a slow, lumbering target. Confident, he armed his cannons and dove toward the nearest P-47. If you're enjoying this deep dive into aviation history, hit subscribe and tell us in the comments where in the world you're watching from. What happened in the next 3 minutes would upend the Luftwaffe's entire concept of air combat. As Meyer closed the firing range, the American pilot didn't bank or turn as the British usually did. Instead, the giant fighter simply pointed its nose earthward and plunged into a dive that shattered every rule Meyer knew about flight performance. He followed, pushing his Focke-Wulf to its limits. The A-frame shuddered violently past 400 miles per hour, but the Thunderbolt kept pulling away, dropping like a stone with impossible speed. At 5,000 feet, Meyer had to pull out. Any faster and his wings would shear off. The American vanished into the haze over the Channel, easily exceeding 450 miles per hour. That night at Beaumont-le-Roger, Meyer's combat report used one word repeatedly: unmöglich, impossible. An 8-ton fighter that could outdive Germany's best interceptors, absorb hits that would destroy a Messerschmitt or Focke-Wulf, and choose when to fight or flee. Similar reports soon flooded Luftwaffe command from every front. Something fundamental had changed in the air war, something German engineers had sworn could not exist. The P-47 Thunderbolt embodied a completely different philosophy of design. While German and British fighters had evolved toward lightweight agility for tight dogfights, American engineers at Republic Aviation pursued brute power and survivability. They built the smallest possible A-frame around the most powerful engine on Earth, the Pratt Whitney R-2800 double Wasp, an 18-cylinder radial delivering 2,300 horsepower. The result didn't need to outturn enemies. It could outclimb, outdive, and outlast them. The R-2800 was an industrial marvel that symbolized America's production might, something the German war economy could no longer match. Development began in 1937, refining earlier radial designs. Its twin rows of 9 cylinders offered superb power-to-weight performance with unmatched reliability. Each cylinder displaced just over 100 cubic inches, for a total of 2,800, hence the name. Yet its real genius lay in the 2-stage supercharger, maintaining full power at high altitude with precision engineering Germany could scarcely replicate. By late 1942, as the first P-47s reached England, Pratt and Whitney's East Hartford plant was turning out over 1,000 engines a month, their tolerances measured in thousandths of an inch. Women who had been teachers and clerks before Pearl Harbor were now building superchargers that ran flawlessly at 40,000 feet in -60 degrees temperatures. The reliability rate exceeded 95%, and replacement engines were so plentiful that damaged aircraft returned to service within hours. Meanwhile, German pilots faced the opposite reality. The once superb Daimler-Benz 601 in the Bf 109 was failing under the strain of bombing and resource shortages. Cylinder heads cracked, superchargers broke, and oil consumption soared. The BMW 801 and the Focke-Wulf 190 remained sturdier, but suffered from substitute alloys that wore out quickly. Pilots learned to baby their engines, because replacements might take weeks. When a Thunderbolt from the 56 Fighter Group crash-landed near St. Omer in May 1943, the Luftwaffe finally had a chance to examine one closely. The largely intact aircraft were transported to Rechlin Test Center, where Germany's top engineers tore it apart. What they found defied everything their doctrine held true. The engine alone weighed over 2,000 pounds, more than some entire fighters in 1939, yet its mounting achieved perfect balance. Its intercooler system squeezed every last bit of power from its fuel-air mix, demanding alloys and machining precision far beyond Germany's capability in 1943. But it was a flight test that truly humbled the evaluators. Oberst-Lieutenant Hans-Werner Lerch, one of Germany's most skilled test pilots, took the Thunderbolt aloft in June. His report described a machine that felt heavy and clumsy on the ground, yet transformed into something extraordinary above 10,000 feet. The turbo-supercharged engine gained power with altitude, maintaining over 2,000 horsepower at 25,000 feet, where German engines wheeze at half that. Lerch dove past 500 miles per hour, where Messerschmitt suffered violent flutter and Focke-Wulf's wrist structural collapse. The P-47 stayed solid, stable, and responsive even at 40,000 feet, still climbing, still powerful. Most astonishing of all, he squeezed the triggers of the 8.50 caliber machine guns in short, measured bursts, and was astonished to find that the Thunderbolt's enormous mass soaked up the recoil with barely a shiver. German fighters, light and delicate, often had their aim spoiled by the vibration of their own weapons. The technical report that emerged from Rechlin in July 1943 made for grim reading at Luftwaffe headquarters. The Americans, it concluded, had produced a fighter that could not be forced into battle if its pilot chose to withdraw. This advantage came not from refined aerodynamics or lightweight design, but from sheer mechanical power coupled with an industrial base seemingly without limits. The report estimated that manufacturing one P-47 demanded nearly 3 times the machining hours of a Bf-109, and consumed specialty alloys already rationed for U-boat construction and armor plate. Yet intelligence revealed that Republic Aviation was turning out more than 200 Thunderbolts per month, with a second production line coming online in Evansville, Indiana. What the Rechlin engineers could not quantify, but frontline pilots understood instantly, was the psychological toll. Luftwaffe doctrine rested on assumptions of technical parity or superiority. German fighters were meant to outperform the enemy, leaving skill and tactics to decide the rest. The Thunderbolt overturned this logic completely. An average American pilot could survive blunders that would have been fatal in any other aircraft simply by diving away at full throttle. A seasoned pilot, by contrast, was almost invincible, choosing when, where, and how to fight. Major Heinz Bahr, who would end the war with more than 200 confirmed kills, encountered his first P-47s over the Ruhr Valley in August 1943. His after-action remarks captured the growing despair among German pilots. They came down on us from above, made one firing pass, and then vanished. We chased them, but it was useless. They left us behind like schoolboys. When they climbed back, they struck again. We could not catch them, and we could not run. Every attack cost us airplanes. This new reality was a product of deliberate American doctrine crafted to exploit the Thunderbolt's strengths. The Eighth Air Force abandoned the idea of turning dogfights, which favored German agility, in favor of dive-and-zoom tactics. P-47 squadrons cruised between 25,000 and 30,000 feet, usually several thousand above German interceptors climbing toward Allied bombers. When enemy fighters committed to their diving attacks, the Thunderbolts would swoop down from even higher altitude, deliver a blistering burst through the German formation, and use their tremendous speed to climb back to safety. This was not the cinematic whirl of one-on-one combat shown in propaganda reels. It was calculated, industrialized destruction that valued discipline over flair. American pilots were drilled never to pursue damaged foes down to low altitude, where the lighter Bf-109s and FW-190s could regain the advantage. Instead, they struck once, climbed again, and waited. The cumulative effect of hundreds of such strikes slowly bled the Luftwaffe dry. By late 1943, morale among German fighter units was visibly eroding. After-action reports began citing reasons like combat decline due to fuel situation or unable to pursue due to altitude disadvantage. These euphemisms masked a simple truth. Pilots were now avoiding engagements with Thunderbolts unless they held overwhelming numbers and perfect positioning. The shift from predator to prey was devastating for men trained their whole careers to hunt. Technical intelligence filled in the rest of the picture. The R-2800 engine, fitted with water injection systems, could produce more than 2,600 horsepower for sharp bursts in combat. This force drove a colossal Hamilton standard four-blade propeller over 13 feet in diameter, larger than the entire fuselage of some early war fighters. The propeller alone weighed more than 600 pounds, yet it maintained flawless balance and efficiency across an enormous speed range unmatched by any German system. The A-frame told the same story of American priorities. Where German designers had shaved every ounce through minimal-gauge aluminum, the Thunderbolt was engineered like a fortress. Its main wing spar was a single forged block of high-strength alloy that withstood forces that would buckle German wings. The fuselage skin was thick enough to shrug off small-caliber fire, and the cockpit was encased in heavy armor plate that turned the fighter into a flying bunker. This ruggedness was changing the calculus of survival. Luftwaffe pilots discovered that their standard rear attack patterns, machine gun and cannon bursts aimed at the fuselage, were useless. Unless they hit vital systems directly, the Thunderbolt often stayed airborne, streaming smoke but flying home. Reports multiplied of kills that refused to fall, limping back across the channel despite damage that would have annihilated a Messerschmitt. By autumn 1943, German intelligence officers were alarmed. The figures told a brutal truth. American single-engine fighter production was not merely keeping pace. It was overtaking German output at a staggering rate. In September alone, U.S. factories delivered over 700 fighters to the 8th Air Force, while total German production for all fronts barely exceeded 1,000. Worse still, American production was safe from bombing, running 3 shifts a day, 7 days a week. Captured pilots revealed the secret: logistical abundance. When an R-2800 failed, it was not repaired in the field. It was swapped out entirely. Replacement engines came from depots stocked with hundreds of spares, while the damaged unit was shipped back to America for factory overhaul. As a result, U.S. fighter wings maintained operational readiness above 80%, while German squadrons often struggled to keep half their aircraft flying. Further study of captured engines deepened the envy. The R-2800 internal showed machining tolerances that German factories could achieve only in prototypes or laboratory conditions. Its crankshaft, a massive, precisely forged spine of steel. The massive crankshaft, built to endure thousands of explosive combustion events each minute, was machined to tolerances within 1,000th of an inch along its entire length. Each of the 18 connecting rods was meticulously balanced to an identical weight, allowing the engine to spin smoothly beyond 2,700 revolutions per minute without the vibration that tormented German radial engines at high power. Yet perhaps the most remarkable aspect of the R-2800 was its dual ignition system, 2 fully independent sets of spark plugs and magnetos. This redundancy ensured that even if an entire ignition circuit failed through damage or malfunction, the engine would continue to operate on the second, suffering only a minor loss in performance. German power plants relied on single systems, where one fault could silence the engine completely. American engineers, however, embraced redundancy at every critical junction, accepting added mass and complexity to guarantee reliability that preserved both pilots and aircraft. The 2-stage supercharger exemplified the same engineering philosophy. Its auxiliary turbine, powered by exhaust gases, pre-compressed the air before sending it to the main engine-driven compressor. Between these stages sat an intercooler that chilled the air charge, raising its density and packing more oxygen into each cylinder. This intricate mechanism had to function flawlessly across temperature extremes, from 300 degrees Fahrenheit inside the turbo housing to 60 degrees below zero in the stratosphere. The turbo's bearings alone demanded exotic alloys and micrometer-precise machining. Containing over 40 separate components, each part was crafted to exacting standards that left no room for imperfection. Yet Pratt Whitney, supported by an army of subcontractors, mass-produced these assemblies by the thousands, maintaining quality with failure rates measured in fractions of percent. When German engineers tried to replicate the turbo supercharger for their own aircraft, they found themselves defeated not by theory but by industry. They lacked the materials, the precision tools, and the labor force to build it at scale. By early 1944, the air war over Western Europe had become a slow-motion industrial collapse for the Luftwaffe. Though the long-range P-51 Mustang drew most of history's attention, the Thunderbolt remained a daily menace, dominating the middle-altitude battles above France and the Low Countries. German fighter units now faced dwindling fuel reserves, grounded aircraft, and maintenance crews struggling to keep worn engines alive. The human cost of this imbalance was starkly reflected in casualty figures. In January 1943, before Thunderbolt arrived in strength, the Luftwaffe lost roughly 130 fighter pilots killed or missing. By January 1944, with American fighters operating in full force, losses had surpassed 400 per month. The arithmetic of attrition was merciless. Germany trained about 2,000 new fighter pilots per year, but was losing nearly 5,000. To fill the gap, training time was slashed, sending inexperienced pilots into combat sooner and dying faster. Those few seasoned veterans who survived into late 1944 adapted by necessity, abandoning offensive zeal for cautious survival. They learned to avoid Thunderbolts unless they held both altitude and numerical advantage, concentrating their firepower on bomber formations to inflict maximum damage in one desperate pass before diving away. Feldwebel Herbert Rohlich of Jagdgeschwader 11 described the grim new rhythm of combat in his March 1944 diary. We climb to meet them. The bombers appear first, contrail stretching 50 kilometers across the sky. Above and behind them, Thunderbolts, heavy and waiting. We set up for one run, knowing we will have 30 seconds, maybe less, before they reach us. Then we dive for our lives, throttles wide, praying the engine holds together until the deck hides us. The physical strain of such operations was immense. German fighters lacked the cockpit heating system standard in American designs. At 30,000 feet, where the air froze to minus 50 degrees, pilots relied on electric flight suits that often malfunctioned or drew too little power from failing generators. Frostbite became routine. Men returned from sorties with blackened fingers and toes. Their oxygen systems posed another lethal flaw. The German demand design required a pilot to inhale forcefully against resistance at altitude, something often forgotten in the chaos of combat, leading to creeping hypoxia that dulled reflexes and clouded judgment. American systems used positive pressure oxygen, automatically feeding the pilot's lungs and keeping his mind sharp. A small difference in technology became a vast gulf in survival. The Thunderbolt's firepower added another decisive edge. Its 8.50 caliber Browning machine guns were supplied by ammunition boxes holding 425 rounds for the inner guns and 500 for the outer ones, over 30 seconds of sustained fire. German fighters, by comparison, typically carried only enough ammunition for 15 to 20 seconds. In the violent, high-speed environment of air combat, where deflection shots and missed bursts were common, the ability to fire longer and more often was a decisive advantage. The .50 caliber itself was a fearsome weapon. Its armor-piercing incendiary rounds could shred the thin aluminum of German aircraft and ignite their fuel tanks. Each gun fired over 800 rounds per minute, meaning a 1-second burst unleashed nearly 100 bullets, a storm of lead and flame that required no pinpoint accuracy. German pilots quickly came to dread its ripping snarl, the unmistakable sound of a thunderbolt closing in from behind. By late 1944, the psychological toll of this unrelenting pressure was unmistakable. Luftwaffe pilots knew that every Thunderbolt they downed would be replaced within days, while every loss on their side was irreplaceable. The Americans had endless machines, endless fuel, endless men. Germany's aces, those who had survived the early glory years, watched their squadrons with as fresh replacements arrive with barely 200 hours of flight time, half the training once required. The balance of the air war had shifted irrevocably. The Luftwaffe's finest were being consumed by the unstoppable momentum of an industrial giant that fought its battles not just with courage and tactics, but with factories, foundries, and a philosophy of engineering that valued endurance over elegance. The Thunderbolt had become not just an A-plane, but a symbol of a world Germany could no longer compete with. By 1944, most replacement pilots entered combat with barely half the flying hours that had been standard in 1942. Major Gerhard Bachhorn, who survived the war with more than 270 confirmed victories, third among all Luftwaffe aces, later recalled a shift from hunted to hunted with painful clarity. In 1940 and 1941, we hunted. We chose when to fight and when to withdraw. By 1944, we were the hunted. The Americans decided everything. They came over Germany in formations that blotted out the sun, protected by fighters we could not match in the air and could never replace on the ground. We fought because duty demanded it, not because we believed we could win. The Thunderbolt's ability to carry external stores transformed it from a pure air superiority machine into one of the most destructive ground attack platforms of the war. By mid-1944, P-47s routinely carried bombs, rockets, or napalm tanks beneath their wings, payloads that would have crippled lighter aircraft. After escorting bomber formations and engaging enemy fighters, Thunderbolt squadrons would sweep down on their return flights to strafe and bomb targets of opportunity. German supply convoys, trains, and troop columns soon learned to fear the sight and sound of the P-47's 8.50 caliber guns. Its immense strength allowed it to absorb light flak that shredded other planes, while its speed made it difficult to hit with heavier anti-aircraft weapons. Luftwaffe airfields became frequent victims. Roving Thunderbolt formations tore through parked aircraft, fuel trucks, and workshops, leaving air bases crippled. These attacks triggered a vicious spiral. Surviving fighters couldn't be maintained because ground crews worked in dispersed, camouflaged shelters, while refueling grew slow and perilous. Returning pilots often found their home bases under attack and diverted to distant strips, separating them from their mechanics and familiar aircraft. If you found this story engaging, don't forget to subscribe and enable notifications. Your support helps keep this kind of deep, historical storytelling alive. Intelligence summaries reaching Luftwaffe command during early 1944 carried ever-worsening news about American industrial might. Captured airmen revealed that the United States was turning out more than 8,000 combat aircraft every month, including over 3,000 single-engine fighters. At first, such numbers sounded like propaganda. Follow-up analysis of shipping manifests, reconnaissance photos, and aircraft deliveries confirmed they were accurate, and perhaps even conservative. Particularly alarming were reports on Pratt Whitney's R-2800 engine production. By mid-1944, factories in East Hartford and other licensed facilities were building over 4,000 of the massive 18-cylinder radials each month, not only for the P-47, but also for the F-6F Hellcat, A-26 Invader, and C-46 Commando. That single engine type alone was being produced faster than Germany's total aircraft engine output of all models combined. The secret lay in a production philosophy Germany could scarcely comprehend. American factories applied automotive assembly line discipline to aircraft manufacture, dividing the complex task into hundreds of specialized operations. Semi-skilled workers, guided by jigs and fixtures, performed each step with practiced speed and precision. Quality assurance was relentless. Crankshafts and cylinders underwent multiple inspections with micrometers, and test cells ran engines through simulated combat cycles before approval. The result was uniformity. An R-2800 built in January ran identically to one made in July, no matter who assembled it. German manufacturing remained rooted in artisan tradition. Components were hand-fitted by craftsmen relying on individual judgment to achieve tolerances. The results were excellent when materials were plentiful, but the system collapsed under mass production demands. As the WWII turned to forced labor and concentration camp inmates to fill its factories, quality control disintegrated. Engines reached frontline units with flaws that would have been rejected in 1942, and pilots paid the price in the air. The divide between American abundance and German scarcity appeared in every cockpit detail. U.S. fighters had electrical systems powerful enough to run radios, heaters, and instruments simultaneously. German systems, increasingly underpowered, forced pilots to choose which equipment to operate during combat. American flyers wore standardized, insulated gear tailored for altitude. German pilots patched together whatever their quartermasters could scrounge: obsolete suits, captured Allied gloves, mismatched boots. Fuel shortages became the final, crippling blow. Allied bombers systematically targeted Germany's synthetic fuel plants and refineries. By mid-1944, fighter units that once received thousands of gallons per day were rationed to mere hundreds. Training flights vanished, and operational sorties were reserved for the most critical missions. Many pilots sat helplessly on the ground as Allied bombers thundered overhead. There simply wasn't enough fuel to intercept them. Germany's synthetic fuel plants, engineering marvels built on the Fischer-Tropsch process, had once sustained the Luftwaffe. Now, under relentless bombing, they became smoldering ruins, symbols of a collapsing war machine that no amount of courage could save. The Fischer-Tropsch process had given Germany the means to synthesize liquid fuels from coal, but its very nature, vast, fixed industrial sites, made those refineries impossible to hide or move. In 1944, wave American heavy bombers, protected by endless ranks of fighters, among them P-47 Thunderbolts, repeatedly pounded these targets. Repair teams restored output for a few weeks at a time before the next raid reduced the plants to twisted metal once more. By autumn, Germany's aviation fuel supply had collapsed to less than one-third of the previous year's level. The situation worsened as feedstock grew scarce and refining equipment failed. Octane ratings plummeted, engines knocked and detonated, and pilots learned to treat their throttles gingerly. Flying into combat in an aircraft that could no longer reach its design power while facing enemies who could push their engines to the limit was a humiliation statistics could never quantify. By the fall of 1944, the Luftwaffe fighter arm was only a shadow of its former self. Operation Bodenplatte, the massive New Year's Day 1945 assault on Allied airfields, briefly showed Germany could still assemble hundreds of fighters for one last strike. But the staggering losses from that single operation effectively shattered the Luftwaffe as a coherent fighting force. Air superiority had not been won through any one grand engagement, but through the slow, grinding arithmetic of attrition, an industrial war that Germany could not sustain. Pilots still flew because orders compelled them to, because duty to their homeland demanded it, or simply because flight was all they had ever known. They no longer fought for victory, only to survive long enough to see the end. The heavy American fighters that had once looked ungainly and cumbersome had become the very symbols of Germany's defeat. The specifications that made this outcome inevitable had been obvious from the start, though few recognized their meaning in 1943. An 8-ton fighter driven by a 2,600 horsepower engine, capable of 500 miles per hour dives and 40,000-foot climbs, represented an industrial capacity far beyond anything Germany could field. The R-2800 engine, mass-produced in plants untouched by war, embodied American power in its purest form. The Luftwaffe pilots who first met the Thunderbolt expected another opponent they could outturn or outclimb using hard-won experience. Instead, they encountered something that rendered their tactics obsolete, a fighter designed not to play the same game, but to end it. The P-47 did not need to outmaneuver a Bf-109 or outroll an FW-190. It merely had to dive faster, endure more damage, and appear in overwhelming numbers. Every tactical success a German ace achieved now served only to underline the broader strategic collapse. The saga of the R-2800 and the machine it powered was, at its heart, a story of industrial warfare and attrition mathematics. Germany had entered the conflict with superior design and innovation in many areas, but wars of endurance are not won by craftsmanship alone. They are won by the side that can replace losses faster than the enemy can inflict them. America's continental-scale factories, safe from bombing, could lose squadrons in 1 week and deliver replacements the next. The Luftwaffe pilots experienced the same arc as their nation, confidence giving way to doubt, then despair. In 1940, they believed themselves untouchable. By 1943, they sensed parity slipping away. By 1944, they knew the end was coming. The Thunderbolt, massive and inelegant yet unstoppable, became the physical embodiment of that truth. In the final accounting, the P-47 Thunderbolt destroyed more German aircraft than any other American fighter, over 3,800 confirmed kills. It flew more than 500,000 sorties, dropped 130,000 tons of bombs, and fired 135 million rounds of .50 caliber ammunition. But its greatest achievement lay beyond numbers. It reshaped the very logic of the air war. It forced the Luftwaffe into defensive tactics, crippled its morale, and hastened its collapse. Those German engineers and pilots who examined wrecked Thunderbolts or watched them thunder overhead were witnessing not just a new kind of airplane, but a new kind of warfare, one where mass production, redundancy, and relentless efficiency replaced craftsmanship and heroism. The R-2800's deep, steady roar at full power, endlessly reliable, endlessly replaceable, was the sound of a world Germany could no longer compete with. Thank you for watching. For more in-depth historical analyses, explore the videos now appearing on your screen, and don't forget to subscribe for future deep dives into aviation history.